please make sure that you have watched all the previous videos of Unit 5. So today we are going to discuss about the last topic in this unit, and it is a very important 5-mark question. Okay, rolling on inclined plane. Okay, so for that I have taken an inclined plane like this. This is the surface which is inclined at an angle theta with respect to the surface, and the height of the angle is h. Okay, this is the height of the the height h from the surface. Okay, now we have taken a ball or sphere or something, okay, which is here, and it is rolling. Okay, not slipping, it is rolling. Okay, so when it rolls, it will be slipping. Okay, right? We know that it will slip. So in order to avoid the slipping, so a frictional force acts here. Okay, a frictional force acts here that we have studied in the last topic. This frictional force will avoid the object to slip. Slip proper roll ஆகிறதுக்கு provide பண்றது யார் அப்படினா this friction. This friction provides a force which opposes the slipping. Slip ஆகிறத oppose பண்ணி proper roll ஆக help பண்ணும். Okay. So now we are going to find out that when this object is rolling. Okay, rolling means what? It will be having translational and rotational motion. Okay. So when this object is rolling in this inclined plane, what will be the acceleration? What acceleration will roll out? Then what is the time taken to reach the ground? Okay. So these two factors. And what is the velocity? Okay. What is the acceleration? What is the velocity of the particle? And what is the time taken to reach the surface? Okay. So for that, let us draw the free body diagram. So this is an object. Definitely there will be a gravitational force acting here at the center. Okay, so this is the it is in contact with the surface here, so the normal force will be exerted opposite to this point of contact. Okay, now this energy in the normal force ku neera endha force illaiya, appo idha nama straight split pannom. One as this is mg cos theta, and the other one horizontal component, this is mg sin theta. Okay, this is mg cos theta and this one is mg sin theta. Okay, so using this free body diagram, we are going to find out the acceleration. First, we are going to find out the acceleration. For that, we are going to use Newton's second law. Okay, so what is Newton's second law? Force is equal to mass into acceleration. So what is the force? Okay, so first let us take this force. Okay, this direction, tangential direction. So there are two forces acting. To accelerate பண்றதுக்கு யார் accelerate பண்றா அப்படினா translational motion கொடுக்கிறது யார்? Two types of motions are here. One is translational and the other one is rotational. So here first let us discuss first to take the translational motion. Translation means we move on. Yeah. So it is provided by this mg sin theta, and it is opposed by a force that is called F. So two forces are acting in this direction. That is mg in the direction that move on. அதனால the first element. புரியுதா? ஏன்னா இப்படி தான் மூவ் ஆகும். யார் ஜெயிக்கிறாங்க? mg sin theta தான் வின் ஆகுறாங்க. அதனால அதோட டைரக்ஷன்ல மூவ் ஆகும். So you have to write first this one. mg sin theta minus f is equal to this. So these are the forces acting in the horizontal direction. Okay. So then what about the rotation? Rotational force கொடுக்கிறது யாரு அப்படினு பாத்தீங்கன்னா, what is the rotational force? It is nothing but rotation means stop. That is this force into this perpendicular distance r. Okay, so force into this perpendicular distance provides the rotation. So the rotational motion is force into the perpendicular distance into force. Okay, that is equal to m. Okay, now both we can write what is a. Okay, so in terms of we can write rotational எழுதும்போது எப்பவுமே moment of inertia எப்படி எழுதணும்? So mass will be written as moment of inertia and acceleration is written as angular acceleration. Okay, so what is moment of inertia? We will write it as mk square. Okay, m means the mass of this object, it is m. So mk square into alpha. What is alpha? Alpha and acceleration are related by acceleration is equal to alpha into r. Okay, so alpha equal to a by r. Okay, so substitute it here. This is equal to a by r. Okay, so from this can you find out here is f is equal to mk square a by r. r square. Okay, mk square a by r, or I can write ma into k square by r square. Okay, ma into k square by r square. Okay, so this is let it take it as equation 1. This is equation 2. Now I got the value of small f. Yeah, in the f frictional in the force வந்து எனக்கு கிடைச்சிச்சு. So அதை வந்து நான் இங்க substitute பண்ணா I can easily find out the acceleration. Okay, so for that substitute in equation 1, that is mg sin theta minus ma k square by r square equal to ma. Okay, so take the a terms to this side. Okay, or this term to that side, or mg sin theta equal to ma plus ma k square by r square. So ma is common, take it out, 1 plus k square by r square. This is mg sin theta. Okay, m and m get cancelled, so a is equal to g sin theta divided by, bring it over here, 1 plus k square by r square. So this is the acceleration provided by the particle. Okay, this formula is very important. எப்ப கேட்டாலும் சொல்ல தெரியணும். Okay, a is equal to g sin theta by 1 plus k square by r square. எப்படி எடுத்தோம் புரியுதா? First take this first second translation motion இந்த ரெண்டு நாளே இருக்கு. இதே பிளஸ் எடுத்துக்கணும்னா இந்த சைடுல தான் மூவ் ஆகும். So mg sin theta, it is an opposite direction, so minus a. Okay, let it be equation 1. Rotation provide பண்ணுறது எதனால? அந்த force into the perpendicular distance. So all f, okay, is equal to, instead of m I want to write m க்கு I போடுறோம், a க்கு alpha போடுறோம். Okay, what is alpha? Alpha equal to a by r. Substitute. Then you will get f is equal to this value. Substitute this value in this equation. You will get it like this. Take it to the next side. Cancel it out. We get the acceleration. Okay. So we have found the acceleration. The next thing we have to find out the velocity and the time taken to reach the ground. Next one we find out the velocity. Okay, for that we have taken the kinematic equation v square is equal to u square plus 2as. Consider the body is at rest, initially at rest, after that it is rolling on. So initially at rest. Okay, so u is equal to 0. Therefore v square is equal to 2 into a into s. Okay, so a we have already calculated. What is s here? Okay, find out sin theta. Sin theta equal to opposite side by hypotenuse. This is yes. Okay, inclined plane of the distance. Yes. So s is equal to what? H by sin theta. Okay, s is equal to h by sin theta. 2 into acceleration. Already we have calculated what is acceleration. That is g sin theta by 1 plus k square by r square. Okay, into what is the value of s? H by sin theta. Okay, so we can calculate sin theta and sin theta. So the answer is 2gh by 1 plus k square by r square. So this is what? V square. If you want v, take the square. That's all. So v is equal to root of 2gh by 1 plus k square by r square. So this is the velocity. Okay, the velocity of the particle. This depends upon the acceleration peculiarity, எவ்வளோ ஹைட்ல இருக்குது, அப்புறம் அதோட radius. Okay, எவ்வளோ அந்த பார்ட்டிகளோட radius, இது எல்லாமே it depends upon. Okay, so this is the velocity. Finally, we have to calculate the acceleration. Sorry, time taken. Okay, finally calculate the time taken to reach the ground. Time taken. So for that we have to take the equation u plus at, and initially it is at rest, so u is equal to 0, v is equal to at. We need time, right? So t is equal to v by t. So what is v? V just now we have calculated. What is v? V is equal to nothing but 2gh by 1 plus k square by r square. Okay, this is v divided by a. What is a? G sin theta by 1 plus k square by r square. Okay, so here we are having root, right? So root length is ready. How can we write? It is equal to root 2gh square the whole square. Yeah. Into, take it upside, write it upside, 1 plus k square by r square by g sin theta. Okay. So when you write it like this one you can write root 2gh by root 1 plus k square by r square. This you can write it as root of 1 plus k square by r square into root of 1 plus k square by r square. Root and root becomes this. Okay. So you can cancel this one and this one divided by g sin theta. Okay. So you can write it as root 2gh into, okay, root 2gh, that is root 2gh into, and also this one you can write it as root 2h root g. Sorry. This you can write it as root g into root g. Here it is root g. So this and this will cancel. Okay. Finally you can write as root 2h. Here also it is root. So we can write it as 1 plus k square by r square. Okay. Divided by here root g. So root g means we can write it as what? Yes, root g. So we can write it in the same root g. Okay. Sin theta. When it comes in root, sin square theta. So yeah, sin root it will become sin theta. So root. So this is the time taken. That is root of 2h. This is also root. So same root 1 plus k square by r square. So here root g. So I have written this g sin theta. The root another root I have written just sin square theta. So this is the time taken for this body to reach the ground. Okay. So it will reach the bottom when it reaches this back. Okay. So it depends upon the height, the radius, the acceleration, the angle. So all these factors it depends upon. Hope you could understood how to calculate when a body is rolling in an inclined plane, how to calculate the acceleration, the velocity and the time taken. And it's a very important question. By this we are ending up the 5th unit. Okay. Hope you could understand all the part of this unit. If you have any doubt, please don't hesitate to ask. Thank you for watching.